Hi everyone. Okay, so we're going to determine the type of quadrilateral using coordinate geometry. You will have problems just like this on your test and on your constructed response. So you need to make sure you know the steps on how to do it and how to explain what your findings are. So let's go ahead and start. We're going to start by the first thing you're going to need to do is find the slope of all of your line segments. So you have A, B, C, D. If you want to graph them, you can, but you do not have to graph them. So we're going to find our slopes of all four line segments. And our four line segments would be line segment AB, BC, CD, and DA. I'm just getting organized here. Okay, so let's start with the first one. First of all, we're going to need to know what our slope formula is. And remember, it is rise over run. Rise is going to be the y-axis, so we're going to have the change in y over. Run will be the change in x. Now I'm just going to look up here and use these coordinates and go ahead and plug them in. If at any time you need to pause this video, you can go ahead and pause, try to figure it out yourself if you want to, and then come back and check and see if it's correct. So between A and B, we have our y's first, so 11 minus 7, over our x's, 7 minus 5. That equals 4 over 2, which equals 2. So the slope of AB is 2. Now I'm going to go to BC. So here's BC, so we're going to have y2 minus y1, so it's 14 minus 11, over x2 minus x1, 1 minus 7, 14 minus 11 is 3, over 1 minus 7 is negative 6, so negative 1/2 is going to be the slope of line segment BC. I'm going to keep going, CD, 10 minus 14 is going to be my change in y, over my change in x will be negative 1 minus 1. 10 minus 14 is going to give me a negative 4. 1 minus 1 is the same as 1 plus negative 1 plus a negative 1, so that's negative 2. Negative 4 over 2 is going to reduce to 2. The negatives become positives. 4 divided by 2 is 2. So the slope of line segment CD is 2. And then we're going to find our last slope of DA. So the A's are going to be our 2's. The D's are going to be our 1's. So y2 minus y1 would be 7 minus 10 over 5 minus negative 1. And of course we know that's the same as plus positive. 7 minus 10 is negative 3 over 6 equals negative 1/2. So as you can see, we're just going to look at our slopes for a second and compare them. And we see that 2 and negative 1/2 are indeed opposite reciprocals. Whenever you have opposite reciprocals, that means that you have perpendicular lines. So if every other set is perpendicular, then you're going to have either a rectangle or a square, because it's not going to be a slanty parallel. It's not going to be a slanty parallelogram, rhombus, anything that slants, because we have these are definitive opposite reciprocals, right? 2 is the opposite reciprocal of negative 1/2. So we have narrowed it down now to square or rectangle. And this is this type of thing you're going to write down for this explain how you achieved it. You're going to tell me, because they're opposite reciprocals, it has to be either a square or a rectangle. And then you're going to go on to your next step, which is finding the distances, so that we can figure out whether or not it's a square or a rectangle. So we know if all four distances are the same, if all four sides are the same length, then it's going to be a square. If opposite sides are congruent, then it's going to be a rectangle. If neither is true, then it's going to be none of the above. So we're going to have our distance formula. Let's write it out real quick. x2 minus x1 squared plus y2 minus y1 squared. And all that's under the square root sign. And I'm going to show you like a little shortcut here. So let me go to let's do AB. Let's write these out real quick. So we're going to have to find the distance of AB, of BC, CD, and DA, just like we found over on our left for the slopes. And what I'm going to show you right now is, if you notice, we already found what y2 minus y1 was and x2 minus x1 was for all of these, right? So I'm just going to use what I found over here and plug it in over here. So for the first one, I have x2 minus x1. Well, for line segment AB, the x2 minus x1 was this 7 minus 5, which ended up being 2. So I'm just going to look over here, and I know that x2 minus x1 is 2, and it has to be squared because I bring down the squared. Then I have y2 minus y1. I know that that's going to be the top part of my slope, so that's 11 minus 7, which I already discovered was 4. So I'm just going to put that right there. So then we're just going to reduce this. So we have 2 squared equals 4 plus 4 squared equals 16, which equals the square root of 20. So the distance of line segment AB is square root of 20. We're going to leave it as square root of 20. We do not need to change it into anything else because all we're trying to do is compare here. So again, we need our x2 minus x1 of line segment BC. So I know that's going to be this on the bottom, 1 minus 7. Already figured out it's negative 6. So I'm going to put that down. Plus, we already figured out our y2 minus y1 is 3, 14 minus 11. So let's go ahead and write that down. Then we're just going to solve this. Negative 6 squared is 36, plus 3 squared is 9, which equals 45. So your answer is the square root of 45. These two are different, so it cannot be a square. All these would have to be the same for it to be a square. So I'm pretty sure it's a rectangle, but we're just going to go ahead and finish just to make sure it's not none of the above, right? So CD, we need our change in x, which is going to be on the bottom here. Negative 1 plus negative 1 is negative 2 squared, plus, then on the top here we had 10 minus 14, and that came out to negative 4. Remember, I changed these to positive later, so we just got to look at the whole thing. So negative 4 squared, and that would be negative 2 squared is 4, plus negative 4 squared is 16, which equals the square root of 20. So I already noticed I already have a square root of 20 up here, right? So these two are going to be opposite sides are congruent. I'm just making up any two sides, right? So if this last one is 45, square root of 45, then we know it's definitely a rectangle. So let's figure out the last one real quick. We have 5 minus negative 1 is the same as 5 plus 1 is 6. So we got a 6 squared plus, and up here we have 7 minus 10 is negative 3. Oops, sorry. Yeah, no, that's right. Negative 3 squared. So then we've got 36 plus, that's 6 squared is 36, plus negative 3 squared is 9. 36 plus 9 equals 45. So the answer is the square root of 45. And as you can see, that is the same as our other square root of 45, which means that these are also equal. So we know that it's definitely a rectangle. So you're going to tell me that it's a rectangle, and then you're going to explain how you achieved your answer. So you're going to show me all this work, and then you're going to tell me it is a rectangle because these two opposite sides are congruent and these two opposite sides are congruent, and because these line segments the slopes are opposite reciprocals, we know that the lines are perpendicular to each other, which creates a rectangle. That is how you find the type of quadrilateral using coordinate geometry. If you look at your other properties of the quadrilaterals, then you'll know what each one is going to be if you end up with, say, a rhombus or a parallelogram. You're going to have to know what all of those properties are so that you know how to identify it once you've found all these things. All righty, go ahead and get practicing.